All right, in 11.4, we're going to talk about applying our different techniques of solving quadratic equations with some application problems. We're going to talk about using that square root property, principles of square roots, where we square root both sides in order to get rid of the square. We're going to talk about how we can use factoring, how we can use completing the square, and or how we can use quadratic formula to solve maybe some application problems. Let's first start by solving some formulas. We've done this before when we were solving just regular linear equations. When we were given a formula with a couple of different variables, how could we actually isolate a different variable instead of one that already is isolated for us? Well, look at example number 1 with me. It gives us looks like a surface area formula. Looks like this is a surface area of a cube. We have a equals 6s squared, and this time we want to solve for s. So we want to get s by itself. You notice that s is here. There's only one s in our equation, but there's a 6 next to it and a squared attached to it that we need to get rid of in order to get s by itself. So let's go ahead and try to isolate s. We're always going to get rid of the coefficient first, so let's get rid of the 6. You notice that the 6 is right next to it, which means multiply. So in order to get rid of the 6, we can do the inverse operation or divide both sides by 6. 6 divided by 6 is 1, so I have a 1s squared, or just an s squared left on that side. Over on the other side, I can't really divide 6 into a, so I'm just going to go ahead and leave it. A divided by 6 equals s squared. Now s isn't quite by itself yet. We need to make sure that we get rid of that squared. We can use our principles of square roots, remember, to get rid of the square by square rooting both sides. The square and the square root cancel each other out. Remember, anytime you add a square root, we should technically be adding plus or minus, but because this is talking about the sides of a cube, your sides of your cube can't really be negative, so we probably are only going to use the positive version of this equation. So we have s equals the square root of a over the square root of 6, or we could say the square root of a over 6. All right, let's do another one. Looks like this might be a volume. I don't know, v equals 3.5 times the square root of h. And we want to solve for h. So we want to get h by itself. I notice that there's one h, and I want to get rid of the square root and the 3.5. Let's go ahead and get rid of the coefficient first by dividing both sides by 3.5. That ends up giving me an equation v divided by 3.5 equals the square root of h. Now I need to get rid of that square root. Do you remember what cancels out a square root? Yeah, let's square both sides. So I'm going to square the right side. I'm going to square the whole left side. The square and the square root should cancel each other out, and I should just be left with an h on that side. On the other side, I have a v over 3.5. All of that is squared, so I can square the v and I can square the 3.5. I ended up with h equals v squared over 12.25. All right, last one's going to be a little bit tricky. Kind of confusing because there's lots of different variables and even a pi, which is a number but actually looks like a variable. And in this one, we want to solve for r. This one's a little bit different because we not only have an r, we also have an r squared. And if you notice, kind of like having an x squared and an x, we can't just go through and isolate x or r and by square rooting or squaring, right? Because there's two or one of each, right? An r squared and an r. So this is actually a quadratic equation, just with a whole bunch of different variables. So we have to treat it like a quadratic equation. We either have to solve it by factoring, completing the square, or doing quadratic formula. It just looks a little confusing because there's no numbers like we're used to. All right, well, let's think about this. If I'm doing a quadratic equation and I have an x squared and an x, one of my first steps is to move everything over to the same side. So in this case, if I have an r squared and an r, I want to move everything over to that side. So let's go ahead and move that positive a over by subtracting it. That means there's 0 left on the left side, and I have an pi r squared plus pi rs minus a. Again, we still have the r and we still have the r squared. So if I'm thinking about this, it's like I said, it's a little bit confusing because we have a couple of different variables. So it might be helpful to kind of imagine this being a quadratic equation with actual numbers. So let's pretend that the pi was actually just a cute little 3, right? It is, it's 3.14, just a rational number. an irrational number instead of a rational number. So let's just make it, instead of pi, a 3 for a second. And then let's take this pi and this variable, which is going to represent a number, and let's just say that that just becomes a 6 when you put them together. And then I have a number in the back, this a. So let's pretend that it looked like this for a second. If I had 3r squared plus 6r minus 9, what would you do in order to solve for r? You would either factor, and if it didn't factor, you'd either try to complete the square or do quadratic formula. If this one doesn't factor, we obviously can't factor if there's variables and pi's in my problem. It's a little bit harder. So let's go ahead and do completing this, not completing the square, but quadratic formula. So if I'm doing quadratic formula, I have to think about what my leading coefficients are, what my middle coefficient is, and what my last coefficient is, like the 3, the 6, and the -9 in this orange problem. So let's go back to our variable problem, and let's try to look for our coefficients. We have our r squared, and in front of our r squared is really a pi, right? We have our r, and if I were to rearrange that, in front of our r would be a pi and an s, and then we have the minus a in the back. So if I'm thinking about my coefficients would be these three numbers. That means my a would be pi, my b would be pi times s, and my c would be negative a. Like in the quadratic formula, a, b, and c. They're just not regular numbers like we're used to. But we can still solve for r by using the quadratic formula by plugging in the a, the b, and the c into my quadratic formula. So let's try that. I have r equals negative b, which is pi and s, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. And you notice I plugged in my coefficients for a, b, and c. Now, we can try to simplify a little bit, if at all possible. I have a negative pi s in front. I have plus or minus. Right here, I have a pi s squared. That means I have a pi s times another pi s, or could I say pi squared s squared? The two negatives from the -4 and the negative a make me a positive, so that's how I got the positive there. I got a positive 4, pi, and a. None of those are like terms with like variables, so I can't really put them together any other way besides that. And then on the bottom I have a 2 pi. Nothing in my problem can be factored or reduced in any way, so it looks like this would be my final answer. I know it's very confusing, but look, we've actually done what we were supposed to. We solved for r. We got r by itself with every other variable and every other term over to the other side. It looks a little bit confusing, but if we knew in our problem what s was and what a was, we should be able to plug in those two values and be able to figure out what r equals using that quadratic formula.